Welcome to Luxoft Tech Talks, a series of podcasts in which IT gurus share their knowledge and discuss the latest trends and innovations in the world of IT. We are going to cover the most recent developments in the programming languages, frameworks, and technologies that are shaping the future of the software industry. This new format of online learning is part of Luxoft Learning Management and Development Services rebranding. Please share your feedback in the comments to let us know what speakers and topics you would like us to cover in later installments.
Welcome to this presentation on simplified state management principles to restore your sanity. My name is Lukas Ruebbelke. I am the VP of Developer Growth at Bug Software, and I just appreciate the opportunity to share a common theme that I see at the function level, the component level, and the application level when developing large-scale non-trivial applications. And so this presentation, the main goal here is that whoever is watching this, that you would start to be able to identify common state management themes, as I said, at the function, component, and application levels of your projects. And so this presentation is going to be in 4 parts. The first part is going to be, I'm just going to talk about complexity. And we're going to take our time there for a moment, because I believe that one of the reasons why we get into trouble as engineers is because we do not appropriately appreciate the complexity of application development. From there, we're going to look at complexity, state management at the function level using RxJS and observables. Then we'll talk about component-driven architecture. And from there, we'll talk about managing state at the application level using NgRx. And so the first act, let's talk about complexity, specifically application complexity. And so this is a quote from a paper out of the tar pit, and it's by Ben Mosley and Peter Marks. And this quote really solidified how I feel about programming and writing large-scale applications. And so if you Google this, it's out of the tar pit. You can find the paper for free. I'd say the first 10, 20 pages are really good. I kind of got lost on the last half, but the main thing is this quote, for me, is how I see programming. And so they say the biggest problem in the development and maintenance of large-scale software systems is complexity. Large systems are hard to understand. Okay, that seems obvious, but what do they mean by complexity? Well, they go on to elaborate. We believe that the major contributor to this complexity in many systems is the handling of state management, and the burden that this adds when trying to analyze and reason about the system. Other closely related contributors are code volume and explicit concerns with the flow of control through the system. So first and foremost, state management is the major contributor to complexity. And in our effort to analyze and reason about that, we increase our code volume and the concerns around flow of control, or how your data flows around your application. And so the point that the concept, or I would say rather the stark truth that I begin to realize is that as your complexity increases, so does your descent into purgatory. And so if anybody has ever inherited a legacy application and you start to go and you look through the code, and I just imagine, as I have been, that you start to get really nervous. And almost maybe this pit in your stomach of like, I have no idea what's happening here. And so on one of my clients, it was a large client, and they had inherited an application from a team that had inherited it from another team. And I hopped on a call and I said, how does this work? And they're just like, we have no idea. We have no idea how this works. It's so complex. We don't know how it works. And so what they ended up doing is, I would think one of the major strategies for combating complexity is just do a rewrite, because they couldn't figure it out. And so as your complexity increases, so does the level of purgatory that you're in. So let me show you a really simple method here. And so what we have is a class with items component, and we have a method that accepts a parameter, and then based on some condition, it does some calculation. And so items component has an inbound method. It takes an item, and then based on the current category, it will perform some calculation. So I've seen variations of this code 1,000 times, 1,000,000 times, many times in code. And on the surface, it makes a lot of sense because you can look at the method and kind of parse out where everything is. So the question is, based on this current category, we get a different, so based on current category, we're going to get a different result if it's fun, cool, or dangerous. So the question is, if I pass in the same object into this method, let's say 3 times, 5 times, 1,000 times, well, what do we get? Well, the answer is we don't know. You cannot possibly know what you're going to get. You can pass in the same object every single time and get a different result. The reason being is because you have hidden state, which we see here. And so depending on the current category, it affects the output of the inbound method. And so this .current category is hidden inside the method. And without actually looking at the source code, you would not know that. Another problem is nested logic. So hidden state, nested logic. And so in the case of dangerous, if current age group is child, well, then we do something different. And so now it becomes really hard to understand what is actually happening in this inbound method. Not only that is the question I would pose when you see nested logic is how do you actually test that in isolation? And so 2 of the biggest problems I see in code is hidden state and nested logic. Moving along, let's talk about state management. So another very simple example, but it illustrates I think the gravity of the situation of not properly handling state. So we have a class inventory that has a ledger object with a total property. And so we have 2 components, items component, widgets component, and both of them are referencing the same ledger object. And so if somebody on the items component says, I need to add this to the ledger, so add sends it in, it gets added to ledger total. Well, the widgets component can do the same thing. So on the surface, this seems very simple. The problem is we have shared mutable state. And so what happens if in the items component, they have a condition or a business rule that the ledger total must never, ever go past 10. And then the widgets component is like, you know what? I'm turning this amp up to 11 and YOLO, we're going to do it. Well, that could cause some really unintended side effects in the items component. So how do they respect that? Well, now all of a sudden, the widgets component has to know about the business rules or the constraints of the items component. And so shared mutable state, in my opinion, is the devil. When you can modify state or a property on an object in more than one place, all of a sudden, anything that references that object needs to know about any of the business rules or constraints that every other place has that's consuming that object. Flow control. So this is a fun example. And this is kind of derived from an example that Jafar Hussain came up with in a front-end master's course. And this was a real problem with Netflix, is what happens when you make an asynchronous call and you want to make sure that the response was successful. And so let's say you wanted to, if it failed, you wanted to try, let's say 3 more times. And so now you could say, okay, we're going to create a retries count property. Notice how we're solving this is we're adding more state to our application. And then if it fails, then we're just going to increment retries count until we no longer have any more retries, and then we're going to reject it. So what just happened here? Well, we added more state, we added more code volume. And so all of this leads to code volume at the end of the day, which then becomes even harder to manage. And so, not to make light of these kind of examples that I presented, but programming is hard, I admit. The reason being is that life is hard. Programming is complex because life is complex, and we are trying to model real life situations in a domain that is complex. So we cannot necessarily rid ourselves of complexity, but we can learn how to manage it. And so this is where, at the function level, we start to look at RxJS and specifically the observable stream. And so just for reference, if you're following along, if you go to the stack blitz here, I have a few examples that I will be referencing throughout the course of this section. So we'll see that a little bit more, but if you want to type this in and follow along, there's a few other examples you might find helpful, please do. All right, so again, state management, code volume, and flow control. And in my opinion, observables are really the ultimate mechanism for tackling this at an atomic level, because it gives us the ability to do state management, control flow, and code volume. And so let me illustrate this. So when we talk about RxJS, first and foremost, what I want to point out is there is a lot of operators that exist around RxJS, but if you don't understand the observable stream, then it doesn't matter how many operators you know, because it fundamentally, the observable stream fundamentally changes the way that you think about applications. So I believe a lot of Angular developers, when they think about observables, and certainly my first foray into them was by using an asynchronous service, so HTTP, and typically what I would do initially is just convert it to a promise. Problem solved. But I would say that when you think about observable streams in the context of only asynchronous calls to the server, you really, I think, limit yourself to just how powerful they are. So we're going to see a few examples, and they're going to be in the DOM. But I wanted to point out that I really want to challenge everyone to think about observable streams outside of just consuming asynchronous data from the server. So observables gives us a powerful way to encapsulate, transport, and transform data from user interactions to create powerful and immersive experiences. So when we think about encapsulation, well, that's part of state management. We think about transportation. Well, that's flow control. And then depending on how we do our transformations, that is code volume. And so we're kind of hitting those big 3 checkboxes. So encapsulation, what that means is you can capture data or an event stream and move it from point A to point B without worrying about the outside world interfering with it. And so this data stream is completely encapsulated. So think of it as a tunnel. Now think of the tunnel as a superhighway in the sense that it's going to move from point A to point B unhindered, very, very efficiently. And this is a really good way to move or control the flow of your data from one place in your application to another. And then along the way of this kind of superhighway is the ability to set up what I would say kind of these micro factories, if you will, or these functions that can transform your data as it moves along the highway so that when it gets to your destination, it's in exactly the form that you want it to be. And so observables are based on two classic patterns. So the iterator pattern and the observer pattern. So the iterator pattern was designed to manage state. And so an iterator pattern is, if you have a collection, you can say, does this have a next item in it? If so, give it to me. And so this is a way to really handle state. The observer pattern is a way to communicate some indeterminate object in the future. And so again, we're talking about state and communication or flow control. This gives us the ability to communicate state over time. And so as an observable stream, what we have is time is progressing from left to right, but there are events that happen that allows us to capture them and then perform some operation based on that event. And so when we think about values over time, this is not necessarily a new concept. We really, I think, intuitively understand this in the sense that you can get a single value synchronously over time via a function, or if you need multiple values through an enumerable. Now, if you need to get a single asynchronous value, well, promises have been doing this for a very long time. The difference is that observables give us the ability to get multiple values over time asynchronously. Another really important distinction to make is that how we get values from a function is we pull it. In other words, you have to call the function or initiate that transaction from your side to pull the results of that data or that operation into wherever you want it. Same thing with an enumerable. With a promise, once a value is available, it will push it to you and resolve the promise. With observables, it's the same way. As values, multiple values become available, it will push those to you. So kind of the fundamental, or rather I would say the general consensus that I get, or the response I get when I talk about observables, is that observables are hard. And remember, I said there's a difference between RxJS operators and observables. And I believe the reason why there's this confusion or the challenge of really understanding this is because people have not taken the time to really truly understand the observable stream. And so this is the foundation of everything I want to talk about in terms of managing state. In an observable stream, or let's say in a normal, not observable stream, so as we think about programming, without an observable stream, we're very familiar with this concept of input and output. We provide input and we get output. So anybody who's ever called a function understands this. This is a fundamental paradigm that programmers learn from the beginning. So this is how we think about programming right now. I think that the most important point that I can make in this entire presentation is this. In order to start to reconcile state management complexity, we need to shift input to output to input. And when you can make that flip and start thinking about, I'm not providing some input and getting output, but rather something has happened that is providing me output, initial output, and I just need to figure out where I want to put it. So with output, there's some event or something that is providing a data stream or information that we just simply have to capture and determine where we want to put it. So if we can stop thinking in an input output world and change that to an output input world, it changes everything. And so let me explain the basic sequence here. So we have an initial output. And so we're not providing input, but we have an initial output. Some event has happened that is going to provide some data. So think of this as if you've ever watered your lawn, you go and you turn the spigot on at the house, and all of a sudden water is flowing. It's through the hose and it's coming out the other end. And so think of the magic in this as your hose. Your final input is where do you want to put it or input it into your yard? Do you want to water your flowers, your grass, spray the kids, spray the dog, fill the pool? It doesn't matter. That's up to you. But there is an initial output that you need to capture, figure out what form you want it in, and then where you want to put it. And so think of this as event, an initial event that's providing output, some operators, and then you simply subscribe to it to get the data in its final form and then input it or make it available to your application. So when I think of observables, I think of it, or I follow this sequence. So the first question is, what is my initial output? And so in this case, we are going from event, and we're listening for a click event on this button. So what is the initial output? Now, what is our final input? Well, it's whatever is in the subscribe block. And so this is initial output, final input. And then what we can do is we can start to stack operators in between your initial output and your final input to change some stuff. And so you can start to stack these in a kind of an immutable fashion to alter what goes into the initial or final, rather, output. So let me hop into some code and I'll show you this real quick example. So if we go here in our basic sequence, and so this is in the stack list that I referenced, we have from event, and because we're using an Angular material button, I'm just having to have a convenience function to get the native element. And I'm saying when this clicks, what I need you to do is take the event and instead take the event and return beast mode activated. So when life gives you lemons, map it to lemonade. And so then what actually comes into the subscribe block is what we've returned here. So we're simply just passing along like an assembly line. So if I click here, beast mode activated. Now what I can do as well is if I just break this into two lines real quick, and I'm freestyling here. What you'll notice is, so I'm going to save this, and I'm going to, and you'll notice every time I click this, it's capturing this event. So now it's an event stream that we're initiating this output. So it's connected to it. And every time a new click event happens, we capture it. And so this is why I love DOM events to explain or illustrate observable streams, because we are constantly firing essentially DOM events that we can capture. So let me take this and let me take this filter and uncomment this. And so this is operator stacking in the sense that what I'm saying here is filter out any event that doesn't have the shift key attached to it. So notice I'm clicking. I'm going to hold down my shift key, and now it's going. And so this is what I'm talking about when I say initial output. In this case, it's a click button, or it's a click event. And then our final input is this beast mode activated. So fairly simple, but I believe this starts to illustrate the point. So we talked about state management. Well, how do we manage state in a stream? So in the next example, we have just a button and a ball, and you'll notice we're using this local template variable, right? And then from here, what we're saying is, well, first of all, we want to capture the click event, but what actually is happening here? So let's walk through this. What's our initial output? It's a click event. What is our final input? Well, we're getting some position object. Whatever it is, we're going to set it. And so we'd imagine that the position object has an X and a Y. So this is what we're using to, this ball is, we're going to move it across the screen. And so from here, we need to then perform some manipulation of the event and then do something to that moves this across the screen while preserving the state within the string. So we do this using the scan operator. And so this is like a reduce operator for an array, is that we have this current value, which is just going to be a number. And so you can see that it would be 10. And then we have this accumulated value, which is just the current value within the stream. So think of it as just like a single loop. And it's the coordinate, it's the current value, which is a coordinate object, which just has an X and a Y. And then from here, what it does is it returns a new coordinate object, and it just increments the X value by 10. So if we hop back into our code, we can go to maintaining state. And so I really recommend pulling this down and checking this out. And so if we go into maintaining state, you can see here, we are taking the event, and it's just a DOM event. We don't want that. We just want to say, make it a 10, and then essentially add this to whatever the current accumulated X value is. What this allows us to do is this. And so what we're doing is we're setting a new coordinate object, but we're preserving or we're referencing the previous coordinate object as our reference point to then add our new X coordinate on. So now this gets really important. And I know we're starting out slow, but this is going to start to make sense once we get into an application level context. What if we have more than one stream? So this is very much like if you've ever been to McDonald's and you get a fountain drink and you take your cup to the fountain, put ice in it, and then you press the button or the lever, and what goes into your cup is, well, you think it's Coke, but in reality, what is happening is you have carbonated water and syrup that are essentially merging or blending together to make this drink. And so the question is, well, how do we make this work in the context of code? So bonus concept here real quick is that you can actually abstract or extract multiple event streams into kind of these standalone observable references that from here you can merge together. And so what we've done here is two of initial outputs or event sources that we're then using merge to say if either one of these emits an event, allow it to go through. And so from here, so this is, we would consider this our initial output. Then we have our essentially our transformation and our final input. So the only thing we're doing here is we're just saying we either want to add 10 to it or subtract 10. So I'll just show you this real quick. So merging streams. So the only difference is we're getting plus 10 or negative 10. And so we're starting to stack kind of these concepts together in a way that we can really start to get into some complex things if we were to follow this through. So one more example I want to show you is how can we sequence these streams? So what if we use streams is not only to communicate data, but to communicate essentially some event that we then use to sequence another stream. So what we have here is some code. So let's walk through this. Initial outputs. Well, we have two here. So from event, and this is move. So what we're listening for is the mouse moving on the document. From the down is we're listening for has the mouse went down over the button. So this is our initial output. And then from here, we have the downstream, and within this we have switch map. And so the question is, when the down event emits some data, what is being returned in switch map? Well, the answer is whatever is in the move block. So we're saying use the down event or stream to initiate the stream, but from here, any information that comes through, send this or initiate or start the move stream. And so this is what's actually going into this bottom block here. And then what we can do is we can say, let's start an up stream. So document, mouse up. And so we can say, when we do a downstream, switch to the move stream until there's an upstream. And so what we've done is, in a very short amount of code, we have managed to do drag and drop very efficiently, very cleanly. And so I'll show this to you, and then we'll move on to component-driven architecture. I think we have a pretty good handle on this. So if we go to event triggers here, notice I can click, I can drag, and when I'm done, the stream is done. So I just started the stream. Now it's on the move stream. And then the minute I let my mouse up, it's no longer following. So this is how you do drag and drop. So you can use these streams to actually sequence other streams, which is really, really powerful. So for the sake of time, let's move on and let's talk about components. And so if you want to check out this Stack Blitz, Angular component architecture, what I'm going to talk about is illustrated here. So component-driven architecture. So we've talked about communicating state over time, control flow, and managing state in a very concise way at kind of a function event level. Now let's talk about how this works at a component level. And so a brief history of Angular. So if anybody's done 1.x, they're familiar with this, is that we started with a tiny app that just had a tiny view and a tiny controller. In fact, it didn't even have to have a controller. And so with AngularJS, this was really exciting, very easy. And so people started to build applications with these. So we had, the view got bigger, the controller got bigger. And then typically what would happen, at least in my case, is I went to my team and I said, I want to make money with this. I want to create an app that can make us money. Let's go. And so this is what really happened, is you create this application that's so big. The view is so big. We're talking thousands of lines of code. The controller is so big that it just collapsed. And so what we would do is, okay, I'm working this controller, but I'm in the first 1,000 lines. So do not touch anything in the first 1,000 lines. And you know, as long as you stay below that, I think we're okay. Not a good way to program. So a few ways kind of emerged our solutions in 1.x. The first one, which was extremely viable, was named routes, is you would just create a named router outlet on the page, and you would just map that to a component and a template, or a controller and a template. Another way to do this was using directives, which you would create a directive, put that on the page, and so you might have like navigation directive, content directive, footer directive, but again, it just had a smaller controller and template. And at that point, React kind of came out and they introduced this idea of really being a component-driven application architecture. And so Angular wisely said, that is a great idea. And so let's just make components the default, is that everything you do is going to consist of a very specific component class and a template. What this allows us to do is it gives us a better structure to organize our applications, as well as it gives us a more efficient way to communicate relevant data or control flow across our application. And so I'm going to assume a basic level of Angular knowledge here, but real quick, data binding. So again, assuming a basic level of Angular knowledge is that when you want to communicate or bind to a property in a template, you use property bindings, which is the brackets. Now, if you want to capture an event from a template, you use event binding. And so we have really property binding and event binding. And so property takes the value from the class, puts it in the template, event captures an event from the template, communicates that to the class. So we have a property binding. We want to bind style.color to whatever component style is. And if somebody clicks on this button, then we want to call the alert the world method and pass in the event. And then we have two-way data binding, which coincidentally, you take two one-way streets, put them together, you have a two-way street, which is why you have the bracket and the parentheses. So event binding, property binding. Now think about this. What if we could create a component that had custom events and custom properties? Well, you can, spoiler alert, and this is in the form of inputs and outputs. And so if you want to pass something from a parent component into a child component, you do this via an input. And if you want to capture something from an event from a child component and handle it in the parent component, you do it via an output. And so the surface area between a parent and a child component is in the template. So assume that in the parent template, we are using the child component selector, adding that to the parent template. And so using property binding, we can send a value into the template, which then gets passed on to the child component via input. And from the child class, we can surface an event via output, which then gets captured via event binding on the parent template. So we have classic property event binding at the parent template, but in the child template, we have input and output. And so what this does is, one, it creates component contracts. And so it's a really nice way to create or define an API for your component. And so if I look at this items list, I can see we have items that goes in, and we have two events coming out, selected and deleted. And so it's really easy to parse what this component can do, which in this case is items list. And so we'll notice that, so inputs and outputs are defined at the child level. So in my component, we're saying I have an input of greeting. And whatever this is, I'm going to render. In the parent component, you are saying, okay, I want to set the greeting property here to hello child. And so the parent component is passing the data in. And then output, we're saying I want to create an event called greeter and so this is an output, but it's essentially, it's an event emitter. So this is based off of Node's event emitter. And we're saying, I want to fire this event using emit. So this is a little bit different because it is an event emitter that you have to actually manually trigger. But we're saying greeter.emit, and you pass child greeting emitted. So you pass some value. And then in the parent template, you can consume this. So notice there is no DOM event of greeter. That's being picked up as an output of the child component, and then we're able to handle that and parse the event. So just a caveat here, in the event handler itself here, so greet, and notice we're using $event. That's just the way the framework works. And so once you handle it in the event handler, it is what it is, but it always has to be $event. So just a little pro tip there, I've been bit a few times. So now, inputs, outputs. Now let's talk about how we can compose these together in a way that can really scale and is, I think, architecturally sound. So container and presentation components come from this idea that really components should perform two primary functions. So I would say this is probably the second most important thing that I'm going to say here. Components should perform two primary functions: consume just enough data to satisfy their template, and capture user events and delegate upwards for processing. So your components by nature should be very, very thin, because you want to move all your application logic and complexity out of your components into services. That's what they're there for. So what we have is a container component that's saying, I need to get all the data to satisfy my child components, or the templates of my child components. So your container component is saying, give me all the data, and then it's passing some of the data into the appropriate child components. Now, at the same time, the presentation components, when something happens, is saying, hey, route this event, do something with it. And so the container component is saying, okay, application process this event. And so this is what a container component typically looks like. And so I'll show you this in just a moment, but notice it is actually, there's quite a bit of stuff happening, not quite a bit, but it's saying I need to get some information, but then also when something happens, I need to do something about it. So save, replace, push, delete, etc. Your presentational components, on the other hand, are very, very thin. They do almost nothing. They're completely defined by their bindings. These are very predictable, stable components. And so the question I would even ask is, how would you unit test a component that doesn't have any logic in it? What are you going to test? And my philosophy is that if you prioritize quality over quantity, you really do not test presentational components. You would test them as, end-to-end tests, but not for a unit test. And so one small caveat here, or I want to talk about this. So mutable state is okay. So this is a slightly advanced segue here real quick, but mutable state is okay. Now, a lot of people, when you say this, because we've been hearing, like, you even heard me say it, shared mutable state is the devil. You should use immutable operations, on and on and on. So what I want to clarify here is that mutable state is okay. Shared state is okay. Obviously, you have to share state across an application. There's times where you have to mutate information. Like, how are you going to update anything? There's zero interaction if you do not allow for mutable state. So mutable state is okay. Shared state is okay. Shared mutable state, on the other hand, is the devil's playground. And so this is the point that I want to make, is that shared state is okay, mutable state is okay, shared mutable state, not okay. And so what I mean here is that, well, so what you have is, in terms of application presentation state, keeping in mind shared mutable state, you have application state that your entire application needs. On the other hand, you have presentation state that is specific to the state of a current component, and it affects the presentation. So you can see here, editing orange item. So this would be the label itself is a presentation, it's the state of the current presentation state of that component, but it doesn't affect the rest of the application. And so when you understand that there's presentation state and then there's application state, what you need to do is then realize, if you have presentation state and application state, where there exists shared mutable state at those boundaries, is you need to essentially make shared mutable state either shared state or mutable state. And so here's how you can do this. So if I have a form, and let's say that shows a selected item, when that gets set, all I simply do to isolate the mutation is I just create a copy of it. And so I have selected item, and I'm just, when it comes in, I create a copy of it. And then if I want to throw it away, it's okay. But if I want to save it, I just push it back up and say, this is the new selected item. And so then from here, this is what I bind to. So I can bind to this copy that I made without actually affecting anything upstream. Because if I didn't do this, I'd start typing in the form, and the item in the list would start to change. So we're in a home stretch now. And this is where we're going to tie this together. So we've talked about observable streams with data originating, so initial output, moving to a final input, and us transforming it along the way. Then we start to talk about components with event bindings and property bindings, or inputs and outputs, that data goes into a component via input and events come out via outputs. And so now, fourth act, NgRx. And if you want to go to the stack blitz, you can see it. So I realized real quick, let me just back up and let me just show you a couple of things real quick. So if you go to the stack blitz, let me show you the container component and some presentation components, just so we have a reference. So an items component, notice here, we are getting our items. And so if I go down here, it's just grabbing them from the item service. But then when events happen, it's saving, creating, updating, and it's just really just delegating this back out. And so this is a container component. So this is what you're seeing here. And if we look in the template, it's an items list and an items detail, and it's just passing in all the items and then the current selected item. And then if we go to items list, and I love this so much, notice there's no logic in here. It's strictly here to present whatever data we put into it and to capture whatever events happen on this component. In this case, it's selected and deleted. And then in here, if we look at our details component, almost identical, with a small bit of logic to isolate our state mutation. So notice here, I can select this and I can change this without changing it here or here. And if I did not create this copy, as I started to type this orange item edited, this would change because it's passed by reference. So with that in mind, let's check out NgRx. And so Stack Blitz, I'll reference, and this is going to be a high level, I think, introduction to NgRx. This is a very, I would say, a more advanced topic, but I think we can get the main point here. So NgRx, keeping in mind state management, control flow, and code volume at an application level is solved by Redux. And so Redux is it's a library for React. So this is capital R, but more importantly, it is a pattern. And so if somebody came to me and said, look, I'm going to a party and I have to impress all my friends about how much I know about NgRx, and I need the 5-minute version, I would say, no problem. Do you understand inputs and outputs? So remember, we have data binding, event binding, property binding. We can create custom data binding with events and property bindings in the form of inputs and outputs. Do you understand this? Yes. And we understand that inputs flow from a parent into a child, and events flow up from a child to a parent. Are we good so far? We have a component contract. Data flows in via an input. Events flow out via output. So input, output. So if you have a parent, state flows down, and events flow up. Input, parent to child, down. Events flow up, child to parent. So I'm going to pause here for dramatic effect. Do we understand inputs and outputs? This is why we stopped at component-driven architecture. State flows down via inputs, events flow up via outputs. You basically understand Redux. Again, what? It's true. So I spent a lot of time trying to wrap my mind around Redux. I think it took me maybe 3 weeks to really understand NgRx, which is Redux with observables. And so this is where now we're going to get practical using NgRx. So what is NgRx? Well, it's the Redux pattern in Angular plus observables equals NgRx. And so the difference is, instead of a parent-child component relationship, is that state flows down. So store through a service, that's a facade, I'll explain that in a moment, into your component class, right into your template. So state flows down. So think of the store as the parent component, and events flow up. You capture an event in the template, it goes into the component class, and then which is dispatched through a service into the store. So the store is essentially, so let me just show this to you at a higher level real quick. So the store is the single source of truth. And it flows, data flows into the component, sometimes through a selector. You use those eventually. And then events flow out via actions. And so really when you think of inputs, that's store.select. And when you think of events, instead of, event.emit, it's store.dispatch, and you emit an action object, which then goes into your reducer that modifies state. So think of these as really the transformation operators in an observable string, very similar, immutable operations that then update the store. All right, so the store is the single source of truth. It sits in the middle of the universe, and everything pulls its application state from there. So application state is accessed via selectors. And so from your component class, you can say, I need to get some state, or need to select some slice of state, and you can do that. So what I like to do a lot of times is look at the kind of the definitions of classes. So with TypeScript, we can click in and we can see the type definition. So if you look at store, a couple interesting things are happening here. And what's most interesting is you have two methods you're just going to use over and over. I've never had to use any of these other methods other than select and dispatch. So think of select as kind of, I need to get this input. Dispatch is I need to emit this action object. Now, one other thing I want to call out is that state is essentially a behavior subject. So it's essentially an observable stream that you can manually trigger data to anybody that's subscribed to it. So it's just an observable stream. And so in a facade, you can say, because we're using observable streams, this dot store select, and you could say flight selectors get all segments. It's going to give you that sub slice of state. And then in your component, you can say, okay, I have this observable stream. Keep in mind that the store returns observable streams. So we're saying I need to get all flight segments. This dot store, we're doing pipe because it's an observable stream. We're saying select all segments. And then in our component, we're just referencing that observable stream. And so a facade is really just, I'll talk about this for 1 second, is just a very, very thin layer that sits between NgRx and your component to abstract out the implementation details of the component or the implementation details of NgRx from the component. So you can either use a different store, You can mock your data out, whatever. All it knows is that it's getting an observable stream. And then in your template, you can do segments, pass that in using the async pipe. It's going to just unwrap that automatically. And so anytime the flight segments change, well, guess what? It's an observable stream. It's going to communicate that down into your template, and it's automatically going to update. Application events are communicated via actions. And so let's see what this looks like. In our component, we're just saying flight facade, load all. And you could do this in the component. I recommend not. So whether you do or not, that's up to you. I like having that separation. And then in our facade service, we're just saying this store.dispatch flight actions, load flights. And so we're dispatching an action. So we'll kind of finish this tour here real quick. Well, what is an action? Well, it's really just an object that we give it a type, and you want to be very descriptive about this. Load flight success. And then you could add in some additional properties to this action object. And then application state is modified through reducer. So in order for, so events flow into the store, but they get routed through the reducer. And what happens here is the reducer is listening for various action types. And then based on the action type, it is updating state. And then what you can do is attaching it to the application. You just simply export this. And this is Angular specific. What we can do is combine these reducers together to really essentially describe your overall application state. And so what I want to do here, and I think we're at a pretty good stop or pretty good place to kind of stop and see what this looks like. I'll show you a quick example. The slides will be available. I'll send them over so you can see kind of the rest of this. But if we go into our stack blitz here, what you'll notice is we have initial state. And so this is just a very simple example, and it's just 0. And so what's happening here, kind of back to this increment, decrement, or left or right, think about this, is we can increment count, or we can decrement count, or we can reset it. And so notice we have state. And it is, so we have application state. In this case, it's just a number. It's a count. And so if we go into our app module, we're saying, I want to attach this reducer, and I'm going to call it count. And then in our app component, or rather our counter component, notice a couple things are happening here. We're saying, I want to increment. Well, what you're doing, and so if we go here, look at the template, click, increment, decrement. And again, this is a very simple example. All we're doing is doing this .store.dispatch, and we're essentially creating an increment action or decrement or reset. And so when an event happens, we're just capturing it and dispatching it so that it gets picked up and it gets handled, but not in the component. And notice here that we're saying, I want to create an observable stream called count. And I want to select the count slice of state. And so when I hit increment, notice there's no logic to update current count. And if we look at the template, we have the count stream, and we're just unwrapping it using the async pipe. And so whenever state changes at the store, anything that is subscribed to that stream is automatically going to be updated. And so this is one, we're managing state in a single place. We're controlling flow. In other words, how does this state get communicated to the rest of your application? Well, this used to be very, very hard, and at least AngularJS 1.x is because, well, if you have a service and two components are referencing a single piece of state and something changes, how do you communicate that? Well, typically using some kind of event bus. Well, events, the observer pattern, it's baked right into an observable stream. And so what I can do is I can actually copy this more than once. And then I can go here and notice they all change. And I'm not having to do anything special to hook up this one or this one, because they're all subscribed to the same observable stream. So we started with observable streams, went to components. Now we're looking at this at an application level, is that whenever count changes, anything that's watching that is going to be notified. Flow control, problem solved. And so I'll show you the actions. These are just very simple. We don't have any props in here. I recommend checking out the documentation, but this is how we're communicating events up. As we're capturing an event via click handler, converting that into an action. So just to recap, and I want to go back to the very, 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 very first slide, and quite possibly we could get some whiplash. I'm going to try to do this very quickly. Is I want to go to this very first quote that I read. The biggest problem in the development and maintenance of large-scale software systems is complexity. Large systems are hard to understand. We believe that the major contributor to this complexity in many systems is the handling of state and the burden this adds when trying to analyze and reason about the system. Other closely related contributors are code volume and explicit concern with the flow of control to the system. Now, we've talked about observable streams. You have initial output, final input, and we are able to manage or handle the state and the flow control of that single event. We have component-driven architecture, container presentation components, where we're able to manage the state of a child component from a parent component, as well as control flow or how data is communicated using outputs or events. And then at the application level, remember, state flows down, events flow up. We're able to do that by consolidating all of our state management into a single application state tree, the store, and then we can select that state or a slice of that state using an observable. State flows down, flow control, events flow up, and because we're only doing it in one place, we are drastically reducing our code volume. And so this is why I'm really excited about this topic, is because RxJS, component-driven architecture, and NgRx gives us the opportunity to address all three of these and simplify our application, significantly reduce the complexity, and just build better applications with less code. And so I know I used Angular as the kind of the example here because it's based on observables, it's baked into the framework. But these concepts apply to any framework that you're using. If you're using React, if you're using Vue, when you start to think about how do I manage state, how do I manage flow control, and how do I maintain an acceptable level of code volume? When you start to think about moving your state into a single place and then efficiently communicating that from point A to point B, you can accomplish all those. And so everything I've talked about, those exist in React and Vue using observable streams, Redux, or some variation of it. And so these concepts are not necessarily framework specific, but rather I think they are framework agnostic and you can use them really across anything. And so to that end, we have talked about some simplified state management principles to restore your sanity. So I thank you for this opportunity. Again, my name is Lukas Ruebbelke, and it's been a pleasure hanging out with you. I hope you enjoyed this session. And to that, good morning, good evening, and good night.